All right, greetings, Saintsmen. We are live and we're streaming the lesson 3.2 instruction. Let's go ahead and get started. We're going to draw the following scenario over and over for this course, and it's this. We're going to have two parallel lines. Now, we've been discussing transversals in the previous lesson. So a transversal is a line that's going to intersect multiple lines. But here's, oh, goodness gracious. Here we go. My apologies. Here we go. So we have lines A and B, not A and A, my apologies. A and B. And these lines are parallel, as we've marked here, okay? And there's transversal C. Okay, so that's what we have in this scenario. So we have two lines cut by a transversal, but specifically here we have two parallel lines cut by a transversal. And when we have that, the corresponding angles are congruent. So let's actually mark out some corresponding angles here. All right. I have angle 1 and angle 2. These are corresponding. Both of these angles are on the, and in this case, they're on the right side of the transversal. One is interior and one is exterior. These are rather straightforward to identify for us. We had the alternate angles, right? One is alternate interior, one's alternate exterior. We also have the consecutive interior angles, and they're all going to have relationships that will be consistent based upon this scenario. So we have angle 1 is going to be congruent to angle 2 because these are corresponding angles formed off of two parallel lines. In this case, lines A and B that are cut by a transversal, which in this case is transversal C. So, show you guys some things here. Here we go. Oh, goodness. What am I doing? New scenario. Let's actually draw these where they look parallel before I even mark them, okay? Right. I have a bunch of angles I'm going to form off of here, okay? Again, we have transversal C, we have lines A and B, and then I'm going to mark these parallel, okay? So we have the arrow that's marked inside on here, and then I have I'm going to number these angles 1, 2, 3, and 4, 5, 6. Oh goodness gracious! And then we have 7 and 8. Okay, and now we have the same scenario where we have two parallel lines that are cut by a transversal. Okay, the two parallel lines A and B cut by a transversal. And we have all sorts of congruency that's now happening, okay? Now, what we had up here is a postulate. And this is an extension of, it's actually very much related to Euclid's fifth postulate, and we're going to discuss this further in class, and the challenges that this has given mathematicians with regard to its truth. Here, I want us to relate all the corresponding angles. So what is corresponding? Well, we have angles 1 and 5. And these are congruent, correct? Because they are corresponding angles. All right. What else? Well, we have angles 2 and 6. What else? We have angles 3 and 7 are going to be congruent because these are also corresponding angles formed off of the two parallel lines cut by the transversal. And last but not least, we have angle 4 and angle 8. So we've now accounted for all 8 angles. They all have a paired buddy that they are corresponding, which, right, they're formed. We have these parallel lines. The line going through them is going to form the same angle each time off of the intersection of the transversal and the parallels. And the reason why, again, these are corresponding angles. This is a reason why. So next, let's take a look at some other things. So I'm going to tell you something else is congruent. I already know that angle 2 is going to be congruent with angle 7. Now, gentlemen, this is going to require some proof. Now, what is the relationship between angles 2 and 7. Well, these are alternate exterior angles. The other alternate exteriors are going to be angles 1 and 8. All right? Well, watch this. I can prove that these are congruent. You guys ready? Of course. I can prove it, meaning I'm going to do a proof. It's a 2-column proof. Now, it hasn't been given to me that these guys are congruent, right? You could just take my word for it, or we could prove it, and we're going to wind up using the following reasons. Now, first of all, how did we start? Well, we already know, because we're going to prove that 2 and 7 are congruent, right? Well, we already know that angles, let's see here, I have angles 2 and 7 congruent. Well, we already know that angle 2 and angle 6 are congruent. Why? Well, these are corresponding angles. It's not that this is given, right? But the reason why is that this was based upon the fact that we had the corresponding angles postulate. So, if 2 and 6 are congruent, well, now look at what we have here. So we have 6 and 7 that are going to be congruent. There you guys go. 6 and 7. And this is through vertical angles. Okay. And then now, because we have 2 is congruent to 6, and 6 is congruent to 7, we can conclude that 2 is congruent to 7 through the transitive property. And what relationship do angles 2 and 7 have? Well, these guys are alternate exterior angles. All right. So could we perform a very similar proof with the alternate interiors? Well, of course we could. So angle 3 and angle 6, these guys are going to be congruent. Moreover, angles 4, oops, just erased my angle 7 on accident. My apologies. What are my other alternate interiors? Angles 4 and 5, right? I could do a similar sort of deal, right? So let's prove the angles 3 and 6. Well, we already know 2 and 6 are congruent because they're corresponding, right? Well, 2 and 3 are going to be congruent because they are vertical. And then, of course, the transitive property, 3 and 6 would be congruent because we already established 2 is congruent to 6 and 2 is congruent to 3. Okay? And again, these are alternate interior angles. So now, when we have the scenario of two parallel lines cut by a transversal, we can make the conclusion that the alternate exteriors are congruent. Moreover, we can make the conclusion that the alternate interiors are congruent. Last but not least, remember we also had one more set of angle pairings, right? Because we've already done verticals, we've already done linear pairs. Now we are talking about corresponding angles, alternate exterior angles, alternate interior angles. But then we have these guys right here, 4 and 6. Well, angles 4 and 6, as well as angles 3 and 5, are not congruent. Instead, these guys have the relationship of being consecutive interior angles. Well, consecutive interior angles are going to be supplementary. All right, which we should be able to figure out because why? Check this out. Well, 4 and 6 are going to be consecutive interior. Well, think about what's the relationship between 2 and 4. Well, those are going to be a linear pair, therefore they're supplementary. And if 2 and 4 are supplementary, then 4 and 6 have to be because 2 and 6 are congruent. We already established this, right? A couple times before. And two angles that are congruent and supplementary to the same, I'm sorry, two angles supplementary to the same angle are going to be congruent. So we've already done this proof before. Let's take a look, guys. This happened. It was back in lesson 2.6, right? It was this guy over here. This is the congruent supplements theorem, all right? We didn't know about this guy. So we don't require really further proof, okay? We don't have to relive that entire theorem. We already have one that's going to help us prove our next theorem. Okay, so a couple more examples. Let's get some more parallels and cut it with a transversal. Now I have this double arrow, which means still parallel. Okay. I have this guy, which is 110 degrees. And then I'm going to put a bunch of angle numbers here. 2, 3, 4, 5, 6, 7, and 8. Okay. Now let's define every single angle measurement that we have here. And we're going to relate it to other angles that we have. You guys ready? So, first, what do we know that's going to be congruent? Well, take a look. We know that angle 4, what's it equal to? Well, angle 4 has to be 110 degrees. You know why? We'll take a look at what's my relationship here, and let's justify it, and we have to do this in parentheses, and this is what we're going to do on our exercises in class. Well, the reason why that they are this way is because they're vertical angles. Okay? So what else? 3 and 4. Okay? Moreover, 3 and 4, or I'm sorry, 3 and 110, which 4 and 110 were the same thing. So angle 3 is going to be 70 degrees because we could say that it's a linear pair. And by the way, angle 4 was vertical to which angle? It was vertical to 110. Well, this is a linear pair with angle 4 or with 110 degrees. But let's relate it to angle 4. So that way we're citing an angle each time. Now let's get pretty exotic here. What else do we have here? Oh, let's find angle 2. Well, angle 2, we should know, is also 70 degrees. Right? Why? Okay. Well, take a look. It's vertical. It's also a linear pair, but I only need one justification, but it's vertical to angle 3. All right. How about angle 6? You guys know this one? Well, what's the relationship with 6 and 110? These guys are corresponding, so this guy has to be 110 degrees. And he's corresponding. Okay. And then, we have 4 and 6, but we already have angle 4 and angle 6. But I want to find angle 5. What's angle 5 going to be? Well, I know angle 3. So I could give a definition here. Angle 3 is already 70. And this guy is going to be an alternate interior angle with angle 3. All right? A few ways we could do this. 110. Ooh, I know what angle 8 is because we already established, right? 110 and 8 have to be the same. What's their angle relationship? These guys are alternate exterior angles. So if I don't give what type of which angle I'm relating to, I'm always relating back to my initial angle 110. And then what's angle 7? Oh, you know what? Angle 7 also going to be 70. Why? Few ways we could do it. I could say it's vertical angle 5. Okay. I also know it's let's use one of our new theorems, right? Like a new toy that we have. Alternate exterior with angle 2. Cool. All right. Last but not least, last diagram we have here. I have lines C and D. And then I have this angle, which is 6y minus 3 degrees. And I have this angle over here, which is 129 degrees. The only other thing I have given is that C is parallel to D, and we are going to solve for y. Now, if C is parallel to D, what do you guys know? And it's that these two angles have to be congruent. 6y minus 3 has to be equal to 129. And then again, remember what we did in the last chapter. In order to justify setting up our problem algebraically like this, we need to give a justification. We're just going to put in parentheses right next to it why we know these guys are congruent, and it's because their relationship. And we have an alternate exterior angles. Specifically, it's when we have two parallel lines cut by a transversal. But that's going to be kind of assumed each time that we do this, okay? When we cite that theorem. That way we don't have to say that mouthful every single time. So, 129, we add 3, it's 132. And then we're going to go here, divide by 6 on both sides to solve for y. 132 divided by 6 is 22. And that's it. So I will see you guys in class. Come see me if you have any questions, and good luck.